Welcome back. While performing capability analysis, we have to keep in mind the data type. A capability analysis for discrete type of data is different than that of continuous data. The common capability indices which are used for analysis assume normality of data, so we cannot use them as it is. In this lesson we'll learn about what are the steps to calculate capability when data is continuous and when data is discrete. As we have seen in the previous lesson, there might be 3 reasons a process is not performing as per the voice of customer. 1. The process mean is shifted from the target value. 2. Process mean is on the target but process variance is very high and major portion of output is going beyond the customer specification limits. And 3. Both process mean and variance are off the mark. The first case can be easily improvised by making the mean of the process shift towards the target value. But, for this purpose we need to evaluate the process performing at less than the desired, and find out the variables which shift the process back to the target. If we find that the process spread is very high, due to which a major portion of output is going beyond specification limits, then we should take measures to reduce the variation of the inputs or the X variables. This will make the process variance or the process spread to reduce, and our output will be more stabilized, and within the customer specified limits. The most common type of problem that we come across is that the process mean is shifted off the target and spread is also more than the desired limits. Six Sigma Primary deals with such problems, and as a Six Sigma belt, our objective is to reduce variance of the process as well as shifting the process towards the target. Though a quick and dirty way to solve this problem could be expanding specification limits, but it is usually not favored by the customer. We discussed this in previous lesson too. Let us quickly revise that so as to stay in continuation for our upcoming topic of continuous capability analysis. When we are doing capability analysis, first requirement is that the process should be stable. If not, we first need to eliminate the special causes, make the process stable and then perform capability analysis. The reason behind it is that a stable process is consistent over time and predictable with respect to the outputs. Just imagine, if we do not have a predictable data, doing capability study is of no use. Time series plots or control charts are used to check stability of the process. We must understand that at the time of measure phase, the process might not be stable. This acts as a mechanism to find out various potential independent variables or the X's which are leading to defects in the output, meaning the output beyond the specification limits. To address this issue of stability, we need to gather a lot of data to establish patterns and find out what should be addressed first. Process capability and performance is generally denoted in terms of sigma level, which makes it easy to understand. The process capability analysis should be performed periodically to understand the actual process performance. While doing capability analysis in Six Sigma project, these are the steps to be followed. First, we select the dependent variable or Y which needs to be improved. Alongside, we understand and verify the customer requirements and establish new specification limits, or for existing specification limits, we validate them again. Sample data for a duration is collected. In case there are any outliers, we eliminate them after ascertaining that no special causes are left. And it is also determined whether it is a long-term data or short-term data. Then, we check stability of the process by plotting control charts, etc. We also have to check the normality of the data. If data is continuous and normal, Z-scores are calculated, and with help of the Z-scores capability indices are also calculated. Then we interpret the results and make inferences. We also create initial capability baselines at this level and calculate current sigma level of the process. This will help us in establishing the facts, during control phase, that improvement has taken place or not. Let us understand step-by-step process of analyzing capability of a continuous process variable. The first and foremost step is to identify and decide the variable for the process outcome under study. In our case study for Alex's shop, we have taken lead time as the output variable, or y, also known as the dependent variable. Since, in measure phase, we have to establish the current process performance with respect to customer specifications, we thus also need to verify and validate the customer specifications. Before starting the analysis, we must ask again about the source of specifications. Whether they are given by the customer or are internally set, are there any compliance requirements, or are there any design requirements, which are leading to the specification limits set for the process. We should also double-check if there is any possibility that specifications may change. Another important point that should be taken care of is that the specifications must be agreed upon, their operational definitions should be set, and concerned employees are aware about them. To create initial baseline, we should go for 100% sampling. This means that for capability analysis, we need to include all the observations in a specified time period. It helps in analyzing variation in short-term data. Though this variation can exist within the batches or groups of observation, as well as between the groups, it is very important to understand and analyze both types of data. Short-term data is collected for a narrower time period, like daily, weekly or shift-wise. Typically 30 to 50 data points are collected, and in this duration we can easily weed out special causes and variation due to that. Thus we can get data from a potentially stable process as well. For long-term data, wider time period is considered. For example, across shifts, weeks, months or quarters. Here we have to evaluate both common and special causes. Typically 100 or more data points are good for long-term analysis. This makes the data more representative of the process performance. We must also understand here that there is nothing like a pure short-term or pure long-term data. The data would be something in between. It is a call we need to take to decide what type of data is in our hands. Typically data from a month or more will come more into long-term data bracket, while a week or a shift's data is definitely short-term. In short-term data, we have the privilege to make process stable by just weeding out the special causes. In long-term data, the source of variation might not just be special causes but common causes also. That is why we call long-term data more representative of actual process. Here note that, if we don't have a long-term data, we should start with the short-term data, and as soon we have more data points covering a relatively longer time of period, we should revise the capability analysis. Now, once we have collected the data, we must first do the sanity check. We should identify the outliers which are stretching the data distribution towards the extremes. We can find outliers through control charts. It can happen in an ongoing process, and special causes behind those outliers can be immediately addressed. Outliers should also be identified when we are doing preliminary graphical analysis, if the data has already been collected. Even after removing outliers, we have to ascertain that the process is stable. This can be checked by evaluating its consistency and output over a period of time. We make use of time series plot or control chart to check stability. Though, in the measure phase, when we already know that problems are there, assuming that the process is stable won't be right. A capability study also is not effective, yet if we find that the process is stable in short-term data, does provide a more reliable estimate of true process capability. And we have to start from somewhere. This short-term stable process can also lead us to some inferences, that if a process, even when there are variables leading to variation, can do better in certain phases of time. What can be done to repeat this? Though this is not the end of finding improvement measures, we have to do even better. In Worksheet 2.4.3 of the exercise book, we can find the data for spindle lengths from two machines, Machine 1 and 2. This is the normality analysis of Machine 1 data. To create normality chart, go to Sigma Excel, Graphical Tools and select Normal Probability Plots. Let us also see the descriptive statistics. The Anderson-Darling normality test shows p-value as greater than 0.05. We can thus say that data is normal. Normality can also be seen in the chart as well, where the data points are almost aligned in a straight line. Exercise book has got the data for Machine 2 as well. Perform similar analysis on that and share your conclusions with your mentor. Since, in our example, we have found that the data is normal, we'll perform continuous capability analysis now. We must again note here that in the measure phase we just want to get a snapshot of current process state. Thus, we should not start focusing on making the process stable right now. We make use of same data for two machines and perform the capability analysis. Now we also note that the subgroup size is 5 and X-bar S chart is selected. Sigma Excel will compute the short-term standard deviation using within subgroup variance calculated for the X-bar and S charts. The Sigma Excel defaults to using a pooled standard deviation to calculate short-term standard deviation. This is the distribution of Machine 1 data. We can see that data is normally distributed. The process is quite off-centered and moved beyond the USL. Both CP and PPR are monitoring indices for the spread of your process compared to the specification spread. CP is used when a process is under statistical control. PP is used when a process is initially starting out. CPK index is -0.66, which tells us they need reduce the process variation and work on centering. Both CPK and PPK can be a negative numbers, and this means that the average process is beyond specification limits. As we can also see that around 56% of total produce is beyond USL. Similar interpretation can be done for Machine 2 as well. Comparing CP values of the both, it looks Machine 2 has a good potential and we can move the mean easily than dealing with variation. Capability analysis does not calculate sigma level. For the purpose, sigma level calculator is available. Feeding the data from the capability analysis in the yellow cells, we can easily calculate sigma level here. As seen in previous slide, if we improve mean so that it goes far from USL towards center, the sigma level can improve significantly. Capability indices assume normality of the data, but if data is not normal it would lead to incorrect conclusions. We should not tend to make data normal. At this point just the actual observations should be taken into account. We can make use of attribute capability analysis in case of non-normal data.